Start the webinar. My name is Ghada Bahig, and I will be starting shortly along with Emmanuel to present the webinar titled IoT Platform Architecture and Market Players. Okay, I'd like to welcome all of you to the webinar and thank basically the Internet of Things Egypt Forum for organizing this webinar. The webinar is going to focus on talking about the IoT platform architecture, the existing IoT platforms that are out there and what they do, and then basically talk about fundamentally what should be the components in an IoT platform architecture and discuss IoT market players in general, not all of them, but basically a selected bunch that we would like to share what they do with you. The presentation today will be presented by Emmanuel Petit and myself, Ghada Bahig, who are both working at Mentor Graphics. So I want to start with talking about the IoT platform, and I basically want to hypothetically make a press release of a first smart bridge. Basically, let's hypothetically assume that there is a company called Doodle Bridge Organization, and Doodle Bridge Organization would like to announce the opening of its first ever smart bridge. I won't talk much. I will leave the picture to basically show you. If anyone comes and tells you this is a release of a smart bridge, how would you view that announcement? Additionally, ZTC Cooperation, also a hypothetical cooperation, announces the delivery and release of its first IoT bridge. NanoHard Cooperation, also a hypothetical cooperation, announces the delivery of its first ever smart IoT bridge. And finally, MGOL introduces the first smart bridge. So I'm basically just showing you that. I know you already have conceptions about this is not a bridge, let alone a smart bridge. So you were able to make that decision because you know what a bridge should do. And that's exactly what we want to do in this presentation, to tell you what an IoT platform, an end-to-end IoT platform should do. So just in a nutshell, to recap, our objectives is to make you aware of the IoT end-to-end platform components. We'll start that by talking about the existing definitions of IoT platforms out there and what they do, and then basically tell you everything that should go into an IoT platform so that you can answer the question yourself. If someone makes an announcement and tells you this is an IoT platform, you can answer the question if this is really an IoT platform and a complete one, or is it missing some components. Based on the theoretical presentation of what the IoT components of the platform is going to be, we're going to also show you an IoT architecture case study, the platform architecture case study, and then we'll jump into discussing what the market players of the IoT domain are right now, the big market players, and hopefully if we have time, we'll just point you out to an easy way to start implementing your first commercial IoT application based on things that are already in place and existing. So the introduction I made is basically to tell you that not every IoT platform is an IoT platform. Right now, the existing IoT platforms out there mainly refer to application enablement platform, and that means that you basically are allowed to develop your application and put it in a platform that allows access to this application via that platform. But with that said, there are currently 4 types of IoT platforms that are given that label. The first category is connectivity or machine-to-machine. And this is basically a platform allowing the ability to connect and manage devices in a resilient, scalable way, which is fundamental to machine-to-machine and many IoT solutions. A range of different kinds of platforms have emerged to assist in this endeavor. Of all the platform types, connectivity support platforms such as, for example, Jasper Technologies and Ericsson are the highest profile. To date, such platforms have been primarily focused on cellular networks and often enable and manage the tasks of initiating, configuring SIMs, and these actually platforms ensure that connectivity paths are managed and monitored and provide some additional tools such as real-time connectivity status, reporting, troubleshooting, and often SIM ordering and profile creation. So this is basically the first category that inhibits or assumes the term IoT platform. The second category is infrastructure as a service backend. So this is basically most of the platforms out there. It's a hosting space for processing power for applications and services. Provides access to computing resources in a virtualized environment. Basically, users of the infrastructure as a service will receive virtual service that they will manage. Big name players in this area are Amazon Web Services, Azure, and Google Compute Engine. So Amazon Web Services is one of the oldest cloud providers, and according to Gartner Magic Quadrant, has the most of the market share. For new customers, they offer a free tier that enables them to use it freely for 1 year with some limited resources. And for a typically new application or website with few users, the resources should be more than enough with this free trial. Azure, on the other hand, is a Microsoft cloud solution. It's intensively promoted and has a large base of customers, notably Apple. The solution is not limited to Microsoft products and can be used on any OS like Linux. And finally, Google Compute Engine. This is the sort of new kid on the block. It's stable and lowering the price continuously, and their data center is limited at this time to a few countries but are expanding. And finally, the third category that inhibits that IoT platform name is hardware-specific platforms. So this is basically some companies that sell connected devices have built their own proprietary software backend, like, for example, Google Nest or Philips Hue. They like to refer to the backend as an IoT platform, but the platform is closed, so you're not actually, as a developer or anyone, allowed to actually do anything on it. Since the platform is not open to anyone else on the market, it's debatable whether one should call it an IoT platform or not. And as I said, a good example of that are products like, for example, Google Nest or Philips Hue. And finally, the last category of IoT platform definition is consumer enterprise software extensions. And that's basically existing enterprise software packages and operating systems, such as Microsoft Windows 10, and they are increasingly allowing the integration of IoT devices. Currently, these extensions are often not advanced enough to be able to classify them as an IoT platform, but they may get there soon. A confusing aspect of IoT platforms is that companies are starting to combine different services. IBM, for example, is combining its IoT Foundation application enablement platforms such as Bluemix, IaaS backend, Jasper and Telet. Two companies have traditionally focused in connectivity M2M space, have now added IoT application enablement capabilities to their offer. So basically, it's like we don't know what should be in an end-to-end platform so that we can say, yep, connectivity is a platform, IaaS is a platform, hardware-specific platforms is a platform, and consumer enterprise software extension is a platform. So in order to answer that question, we basically prepared this table for you, and it shows the components that should be in a complete IoT platform. The first component is basically connectivity and normalization. So before jumping into that, typically an IoT platform is, if we're just talking about a simple definition, is about enabling connectivity between things or devices. The architecture may also consist of a software platform, an application development platform, or an analytics platform. In a more sophisticated form, a true end-to-end IoT platform would typically consist of all these layers. The first would be connectivity and normalization. And this is basically the intention of this component or layer, is to bring different protocols, communication protocols, and different data formats into one software interface, so that you ensure that accurate data streaming and interaction with all devices is possible. So typically device to cloud, but also more difficult, cloud to device. The second layer that is also a must-have in a complete end-to-end IoT platform component is device management. So the layer of device management is basically to ensure the connected things are working properly, seamlessly, running patches and updates for software applications running on the device or the edge gateway. So for example, if you have a sensor or you have any embedded device that's connected, your end-to-end platform should allow this, the platform should allow that you basically run diagnostics on your sensor, detect issues, run updates, run firmware updates. You can do any of these device management activities. It includes also device provisioning. So when you first plug in the device, you can provision the device, create and maintain an accurate avatar shadow object of the real device on premises. You can configure the device, so set parameters, for instance, firmwares or applications, secure the system, so communication confidentiality, mutual authentication of the device and the back end, resource access authorization. So all these part of the device management, the ability basically in your platform to manage your connected devices and talk to them and do provisioning and configuration of these remotely connected devices. Database, definitely a component that everyone expects to be there and knows exactly that it should be there. So it's basically a scalable storage of device data, bringing not just device data, of course, but data, brings the requirement for hybrid cloud-based database to a new level in terms of data volume, variety, velocity, and veracity. So it's not only device data, as I said, but all the data that is potentially surrounding the object. So for example, user data, application data, the APIs, the open interfaces that are on the cloud, for instance, to access the embedded devices, these kind of data, utilization history, device topology. So any data that is pushed as part of your device or as part of your application space is basically hosted in this storage part of the platform in the databases that are supported in that platform. Processing and action management brings data to life with rule-based event action triggers, enabling execution of smart actions based on specific sensor data. For example, a big example of that would be the if this then that environment. You probably heard about this, where you go in and you start defining rules such as, if it rains, I don't want to turn my irrigation sensor on. If the weather is hot, is cold, I don't want to turn my AC on. So basically putting rules that controls your devices. And these rules are based on events that you can automatically collect into the cloud and actions that you can automatically take from the cloud. Definitely analytics. Everyone expects the IoT platform to include an analytics component. So this performs a range of complex analysis based on the data that is stored in your platform, from basic data clustering, deep machine learning, predictive analysis. The intent is basically to extract the most value out of the IoT data stream. And this is basically, it starts here when we're talking about such additions, we start talking about the application space in this IoT platform. Visualization, so the ability to basically map the data that you have captured in your IoT platform in visualize dashboards where data is portrayed, for example, through line stack, pie charts, 2D or even 3D models. If I want to see the temperature over the last 3 months of a specific place, I really don't want to see a table that is showing me the temperature reading every 10 milliseconds. I want to see a graph so that I can predict, for example, or I can map where the anomalies were compared to a specific other events. So visualization should be supported in the IoT platform as well. Additional tools include, for example, the ability to allow IoT developers to prototype, test, and market the IoT use case, so creating platform ecosystem apps for visualizing, managing, and controlling the connected devices. External interfaces, finally, it's basically integrating with third-party systems and the rest of the wider IT ecosystem via built-in application programming interface, so APIs, software development kits, SDKs, and gateways. External interfaces should actually be integrated as part of the IoT platform, and a good example would be, for example, again, as I said, the if this then that, where you're basically just communicating with the devices via interfaces that can be integrated into an IoT platform. So with that said, I will move to the case study, and I will let Emmanuel proceed in this part of the presentation.
Okay, thank you very much, Ghada. I hope you can hear me okay. So I will be talking you through a few slides, the intent being to discuss the building components of a platform, like Ghada pointed out initially. We will review in the following order things like topology. Then we will be discussing the cloud stack. I'm just going through the quick agenda of that part of the presentation. So topology, cloud stack. Then we'll be discussing the gateway capabilities, and finally I will say a few words about end-to-end security. So this slide here is about the first type of topology, the typical topology where every device is connected directly to the cloud. So in that type of architecture or topology, every device has to have a connection, obviously, and the cloud manages the device, and the device uploads data to the cloud. So it's kind of the very basic enabling topology for IoT. This is not the most interesting in my opinion, but this is the most historical one for sure. The next topology, the next slide, Ghada, is a topology where there is basically a gateway or an aggregator between the device and the cloud. And having that on-premise gateway brings a series of added value, which I would basically split into basic added value or first level and more advanced added value. So as far as the basic type of added value a gateway brings, obviously the gateway, because it has multiple radio, multiple physical interface, allows a first level of aggregation. So the devices can be of various types. They can be Bluetooth, or they can be Wi-Fi, they can be Ethernet or USB. The gateway will basically aggregate, normalize, right, those data, and be in the situation to push them to the cloud. So this is the aggregation kind of enabling technology, enabler. The other first level of value add is the fact that the data may not go straight to the cloud, in particular if they have to be compressed, or if not all of the data are meaningful at the same time. For example, the gateway can have compression or some kind of correlation logic built in, so that it will only upload to the cloud data at a different rate, basically, or based on different triggers. So this is the second type of added value, typically compression, I guess, and isolation, like first level of compression, I would say. The series of more interesting and more advanced added value such a device can bring should start to materialize when the device is actually powerful enough to become more like a local server. So this is the smart gateway type of paradigm. Now the gateway is not just an aggregator or a data normalizator, if you will. It is also a local computer that has local intelligence that can be for device management, but also for application. So if that device, and this is obviously the expectation, that the device is able to host local web services, local logic, complex algorithm execution, then the device becomes like a node, a server on-premise, and use cases that would otherwise not be possible due to internet latency or response time becomes possible. The gateway becomes an on-premise real-time server, and therefore the use cases are much richer. Yeah, I guess that's it for that topology. We can switch to the platform architecture. So this slide is about the various layers of a typical backend stack, I would say. So it all starts obviously with the infrastructure as a service layer. So this is where the cloud provider offers compute power and basic data storage. So the idea is that a good platform should have independence and separation of layers, and therefore should be able to support or be hosted on any kind of public cloud as well as private cloud as required. So public clouds, Amazon, Google, Azure, any cloud should be capable of hosting the compute engines and the data store of the platform. Then those infrastructure as a service, this infrastructure as a service layer interfaces itself with the next layer of the typical IoT stack in the cloud, which is the platform as a service layer. So this is when the server becomes specialized. Like on the first layer, what you get basically is a Linux machine on an Amazon instance, for example. Then when you go to the next level, the PaaS layer, you have your Linux server becomes a database server or a messaging server, maybe an application server. Those operations, this kind of specialization of the server, that built up of the server is called server provisioning or commissioning. And this is automated by that PaaS layer, or otherwise called the cloud management layer. So that's not the only thing the CMS layer provides. It also offers the ability to scale the server based on triggers. So if the server is heavily utilized or is having a lot of CPU load or traffic, the CMS layer will detect the event and trigger more server in that particular tier. So that's called scaling. The last big piece of the CMS layer, which is the previous one, the last piece of that platform as a service layer is the monitoring. So this is basically collecting all the information about server utilization in view for the administrator of the server to audit its deployment and understand the utilization and whether it is worth to have an expensive 16-core server to do a type of service that maybe could be rendered by a less expensive server. So this analytic and monitoring at the server level is kind of an audit and optimization capability among other things. So going up into the stack, which is the layer being shown at the moment. So on top of that platform as a service layer comes typically the software as a service layer. So this is where the services of the platform, the specialization of the platform becomes real. This is typically implemented in the form of a bunch of RESTful APIs like HTTP services. You would expect those services to be managed, meaning that not every one that shows up on the internet can actually access to them. You have to subscribe, you have to get credentials in order to utilize those services. And those services, because we are talking about an IoT platform, those services would terminate typically either on the device itself, but also on the avatar or on the metadatabase that represents the device in order to retrieve attributes or drive parameter settings for the device. But the idea and the important thing is that this software as a service layer, so this is really the interface to the external world, and the expectation is that those services are RESTful APIs typically. You're going a bit too fast, Ghada. Yeah. The last layer of the of the IoT stack that basically consumes those managed RESTful services, that's the application space. So the application space is really where the IoT use case, is implemented. Everything, been underneath or at the RESTful services layer and underneath is kind of an infrastructure and a middleware support. When you go up to the application space, this is where you implement your real use case. So the application implements itself in the form of web services, obviously, but typically you also have application in the form of mobile application. And like I was explaining before, the application may have a component on the gateway itself. If the application has a need to have local services or does local logic, then the application has a contributing component inside the smart gateway. Right, I think that's it for the stack. Now we can proceed to the next slide. So this slide is about the enabling capability of a gateway. So gateway is a term that usually refers to a device that adapts a given protocol to another. It's basically referring to the aggregation and data normalization role of that device. But like I was explaining, in the IoT, you want the gateway to be smart. You want the gateway to be more like a managed server than really just an aggregator. So that's why smart gateways or advanced IoT gateways would have more than just connectivity, but they will be a real managed server, meaning that not only it will aggregate data from various radio interfaces or wired connectivity, but it will also be programmable in a way that those data can be adapted to the application to be compressed, processed. The gateway, the smart gateway, can actually even drive actuators locally without having to report to the cloud for any kind of decision. And then, of course, the cloud connectivity to the gateway would augment the capability of the local use case by doing any kind of non-critical reporting. So the upload of IoT data cannot be time critical. So this is the one typical use case of IoT, but I guess, and I hope you understand that once you have a smart gateway on premise, you can do much more. You can make that gateway the control point of your IoT application, and that control point is manage, real-time, low latency. So that's what this slide is about. I think I mentioned the routing capability, all the connectivity, so we can proceed. Yeah. The last piece of that quick overview is about the security. So certainly this is not, this one slide is not meant to cover the IoT security in its entirety, but I just wanted to, kind of mention the security from the end-to-end perspective. So security in an IoT system is, needs to have a contribution on the gateway or on the devices. So this is what is on the top, at the bottom, sorry. So every device needs to have infrastructure for security. That infrastructure for security on the device, it means that the device needs to have secure storage and, as much as possible, secure execution environment to carry out any kind of authentication and crypto security operation. So usually this is implemented in the form of a secure element, which is a special, microcontroller with tamper-proof security. In addition to the secure element, the device needs to have special security-related services and need to be able to follow a proper provisioning flow. You don't want that an IoT gateway is kind of like a computer or a PC in your home that you can connect to, start installing software and play with it. It's really not the case. Those gateway has to be managed, meaning that every single piece of code or content that is pushed to the gateway is authenticated and verified by the system, generally speaking, right? So firmware, application, all that has to be provisioned, authenticated, and verified on board the device. In the upper part of the diagram, so the other end of the solution, which is the cloud, you need to have this kind of infrastructure as well. So the cloud needs to provide a secure server and secure storage for the same reason, which is authentication and verification and security, signature of every component that is going into the device. All the servers obviously have to be secured from the internet viewpoint. So this is about firewall rules. This is about all the backend security, that needs to be implemented. Similarly, I already mentioned that in order to improve the security of your backend, you don't want that your servers are kind of manually managed, meaning that there is some kind of IT guy that goes into the server and decide to update or not the latest package. All those operations, they have to be automated, via a proper platform as a service layer or cloud management system. In the space of services in the backend that relates to security, so you need to have, when it comes to an IoT platform, you need to have a tight control of the users. What users has access to what device, or what administrator can administrate what device. So all the user profiling and the resource management and the authorization of the resource access, those are, typical security elements you would expect to have. So access permissions, management of API. So this has to do with subscription. This is usually implemented by OAuth token and SSL certificates. So this is the kind of technology that are under the hood of all those features. So I will conclude with the security of the data in motion. So here, this is not new. The IoT does not bring necessarily or does not need more security than other for data in motion. So SSL is in order to encrypt the communication between the device and the backend. So you would expect to have for sure SSL communication. And the last piece is the authentication. Unlike when you have anonymous users that connect to a server, what you want is that every managed device that signs up or connects to the backend is authenticated. So it's not about just the device authenticating the backend. It is also about the backend authenticating the device. So what you need is a mutual authentication between device and backend to basically avoid any kind of intrusion into the system. So that concludes the quick overview of platform component. And now I'm turning back the control to Ghada.
Okay, so we'll move to the nearly last section of the presentation or the webinar, which is to basically give you a quick summary of top IoT market players. So we talked about Amazon Web Services. It's basically in 2015, Amazon Web Services launched its Internet of Things platform, which uses tools like Kinesis, real-time streaming service, S3, the simple storage service, and DynamoDB, which is massively scalable NoSQL database. Dell is offering endpoint connectivity for devices, so plus back-end storage and analytics platforms to manage IoT data. In 2014, Dell opened its IoT lab in Silicon Valley in partnership with Intel. AT&T, the company has launched M2X, basically machine-to-machine or machine-to-human. It's a cloud-based data storage service and data flow, a development portal for building applications for the world of IoT. AT&T hopes to have 10 million vehicles connected to its network by 2017, including 1.2 million fleet vehicles and nearly 240,000 shipping containers. Bosch says its range of products will be connected to the Internet of Things to ease maintenance and monitoring of devices, making it one of the key enablers of IoT if it delivers on its promise. Plus, the company has built an IoT cloud to process all that data. Cisco has carved out a range of IoT services from network connectivity, including switching, routing, wireless access, and embedded network hardware, to fog computing services, which bring data collection, storage, and analysis to the network edge, to data analytics, security management, and automation. General Electric is credited with coining the term the industrial Internet of Things to depict the idea of connecting devices used in manufacturing to the Internet. It has an IoT platform called Predix. It's a cloud-based data and analytics service, is another pillar of GE's IoT plans. So Google, on the business side, Google says its combination of fiber optic backend network combined with its massive public cloud mean that it is in a unique position to serve the needs of IoT. And recently, it just launched Android Things, a new OS for IoT gadgets. Mentor Graphics has an IoT gateway connecting devices and cloud edge server. It also has an end-to-end platform, CSP, for device management, data aggregation, remote provisioning, databases, and security control. Additionally, it adopted Eat Your Own Dog Food slogan by basically using its own platform to provide vertical services in the smart lobby solution. Hitachi, the company is partnering with Intel to ensure its machine and industrial equipment are connected. On the HTS side, the company is rolling out new cloud-based platforms to collect and analyze IoT data. Huawei released Light OS. It's a micro operating system for IoT devices. It joined the Cloud Foundry open source community to help create an IoT application development forum. Oracle, as expected, is building connections for its SQL, NoSQL, and databases to ingest IoT data and integrate data back into the company's applications. It has an IoT service and IoT cloud that prepackages these workflow services into a product. And IBM basically is in the platform as a service domain. So it has IBM Bluemix, which is a cloud platform as a service developed by IBM. Intel wants to be the company supplying silicon for the Internet of Everything. The company has rolled out a variety of products to serve IoT, from its Quark line that provides low power computing for small form factor appliances to Atom processors that are ideal for rich graphic rendering. Microsoft has rolled out an IoT suite for its Azure public cloud, which includes IoT Hub for users to connect, monitor, and control devices, a streaming analytics service combined with machine learning, a notification hub for sending messages across IoT devices, and Power BI. PTC bought ThingWorx, an IoT application development platform, Axida, a cloud service for managing connected devices and processing machine-to-machine data, and Cold Light, which is a machine learning artificial intelligence platform for analyzing data. Salesforce it has introduced its IoT cloud powered by its real-time processing engine named Thunder. It's not just about what they say is basically that it's not just about connected machines, it's about connected products and marketing as well. Samsung promises to make all of its devices IoT ready by 2020. The company is developing a series of ARM chips for its devices, along with APIs that it says will allow its devices to connect to any IoT platform customers want. They also offer a public cloud called Arctic that enables connect and play of embedded devices. Siemens, as General Electric, is in the industrial domain, so it's working to connect its devices and has partnered with SAP to provide the analysis while also building customer software for what it calls the Web of Systems. It has its cloud called MindSphere and several gateways for industrial domains. HP acquired vendor Aruba Networks for $3 billion to tap into the IoT market, and they will aim to produce connected hardware like routers and switches. Symantec, they got new software that goes to a large variety of these small footprint devices, like, for example, sensors and the platforms, and can do things like end-to-end encryption and authentication. SAP launched its SAP HANA Cloud Platform for IoT, which includes a range of data and application services. HANA includes predictive analytics, telematics, geolocation capabilities, while other IoT services are new, like, for example, device management, IoT messaging, and IoT application enablement. Qualcomm started the All Join initiative, which aims to create an open source protocol for IoT devices, to introducing a series of IoT optimized chips named Snapdragon, to offering a variety of connectivity services and platforms. Facebook, not expected, but basically parsed is Facebook's back-end mobile platform that now enables developers to create IoT apps, supporting major chip manufacturers such as Intel, Atmel, and Broadcom, a back-end as a service for microcontrollers and real-time operating systems. And Freescale, basically multiple reference designs based on IMX6, Sabre for media, for networking gateway, and software from partners such as IBM and cloud services. So in a nutshell, as I indicated, I'm not listing all the players that are out there, but in a nutshell, what I want to tell you is that a lot of the big players are basically diving into the IoT domain because it is expected that the next chunk of revenue in billions will be coming from that space. So with that said, I just wanted to give you a quick, step by step on how to build your first application, but just to give you pointers on what you can do to basically start developing an IoT app without having a lot of capabilities or depending on existing huge infrastructures. So several smart devices are available with their gateway, and you can purchase them via Amazon, like for example Google Nest or Philips Hue bulbs, and the smart devices public services are accessible. So for example, if you buy a Philips Hue and you want to turn on the light or turn off the light or make it dimmer or change the intensity, all the interfaces to derive that bulb is actually published and available through Philips Hue developer portal. Also, some of the clouds offer connectivity to such embedded devices that are available on the cloud. So if you go and buy Philips Hue and then you subscribe to a cloud like, for example, the Samsung Arctic, it will automatically allow you to connect to your Philips Hue and derive values or derive the Philips bulb via the Arctic cloud. You can do it manually via a dashboard portal, or you can actually do it via calling HTTP RESTful API. Now, in order for you to simply start developing your mobile application, you can do very simple steps. So for example, if you buy one of the connected embedded devices and you access through its open developer portal the interfaces that can empower you to change the behavior of that device, like the Philips Hue, then you can basically create, just by developing a mobile application, create an IoT app. So for example, Philips Hue has provided the open interfaces, and the devices are available on Amazon if you want to buy it. And if you go to the iTunes or to the Google Play Store, you will see that there are a lot of applications that have not been developed by Philips. So things like, for example, turn the music into light, or match room light to movie light, or control hue with voice. All that is basically based on developers that basically grabbed the product and the open interfaces, and they basically decided to start developing a smart application based on that. So simply, if you buy that product, for example, and you initiate a sequence of steps, like, for example, discover the bridge IP, which is a public interface available by Philips Hue, generate a user token, and then call services that control the light, and then you can put your own mobile application program or software that basically calls these interfaces and does things depending on other triggers, and basically create your own creative first IoT application. So with that, I basically conclude the presentation. I hope it was useful, and we'll be open for questions. Okay, I see that right now there are no questions, so I believe that concludes the webinar, if I'm not misunderstanding anything. And please, I believe that the webinar is recorded, so if you have any need to actually listen to any of the content that was done, you can later on access the recorded version and view it again. Thank you for your attention, and looking forward to the next webinar.